All right, we are on page 5 of your notes. So we're going to talk about logarithms. This is a new topic to you. Have your power card handy. Have this handy because we're going to use this a lot. I don't know if we're going to use your calculator hardly at all. Yeah, so let's dive right in. Here's what it says right in the warm-up. 2 power x equals 8. What is x going to be equal to? Right away I'm thinking, answer's 4. Because 2 times 4 is 8, right? Well, this is actually the activity that we just played. It said, all right, start with a 2, end with an 8. What's the exponent? So if we go to our paper, start with a 2, end with an 8. The exponent is actually a 3 that changes a 2 into an 8. So the answer is going to be a 3. Well, that's nice. Let's try another one. All right, how about start with a 2, end with a 20? So start with a 2, end with a, oh boy. We know that the answer is between 4 and 5, but we don't know what the answer is. So the question is, how can we figure that out? And the answer is a logarithm. By the end of the section, hopefully we'll be able to answer this. So what in the world is a logarithm? I'm going to take you on a quick tour of mathematics. So back, I don't know, kindergarten, first grade, you learned how to add. We all like adding because it's easy to understand. And we did problems like 2 plus 3 is equal to 5, like that. Well, it's not long after you learn to add, you also need to learn to subtract. So what we could do is we could take those very same numbers and just put them in what I would call subtraction form. So 2 plus 3 is addition form. And if I go 5 minus 3 is equal to 2, that would be the same numbers, but in subtraction form. I guess you could go 5 minus 2 is equal to 3. That would work as well. So addition form versus subtraction form. These are opposites, so the same numbers can be written 2 different ways. All right, maybe about, I don't know, second, third grade, you learn how to multiply. Multiply. So you did problems like 3 times 2 is equal to 6. Well, not too long after you learn how to multiply, you need to learn how to divide. So I could take these numbers written in multiplication form and I could put them in division form. So 6 divided by 2 is equal to 3. Or I guess you could go 6 divided by 3 is equal to 2. It works out. This is multiplication. Take the same numbers, rewrite them in division, and it works out. All right, the next one, add, multiply, divide. After that, we learn powers. We learn about powers. Okay, powers are problems like this, like x squared is equal to 9, things like that. And then, so this was actually, you probably learned it in maybe 6th, 7th grade, but we just hit it in the past couple months as well. Well, we would know that this was going to be equal to 3, so we could put a 3 in here. So 3 squared is equal to 9, like that. But I also, once you learn about powers, you can also learn about roots. So I could take these same numbers and rewrite them in root form. Well, the opposite of a square is a square root. So I would say square root 9 is equal to 3, like that. So these are the same numbers. This is power form. Rewrite it in root form. All right. Well, let's get back to this top thing now. If I have 2 power x is equal to 8. That's what we call an exponential form. This is an exponential equation because the variable is the exponent. It's up there. What's the opposite of an exponential? That's a good question. If we have a power 2, that's a square, we have square roots, but power x, do we have an x root? Is that such a thing? Well, what we have is actually called the logarithm. If I would do this, here's how a logarithm works. It's going to say, we're going to rewrite it like this. I'm going to have log base 2. You're actually going to write out the word log, which is kind of a weird thing to do. Then you're going to have a number that's lower, and then a number like this of 8 that's going to be equal to x. We're going to rewrite it just like this. Logarithms and exponentials are inverses of each other. Well, at first you're like, whoa, what's going on here? Here's how this works. The first number is the number you start with. The second number is the number you end with. And then it asks you what's the exponent that changes the first number into the second number. So this is your exponent. So really, if you understood the game that we played right before this, you'll get it. You'll say, well, okay, I start with a 2, end with an 8. What's the exponent? Just go on here, start with a 2, end with an 8, with the exponent. So, we do have to know the notation, but I think you can handle it. So let's try a couple in log form. I'll try one, then you try one. So here's how it goes. The base is 4, the exponent is 6, and the answer is over here. According to logs, we're going to go like this. We're going to write the word log. The base here is a 4, so the log of our base is going to be a 4. We're going to log the number over here, which I would call the answer. So the number on this side, 4,096, and it's going to equal to 6. And well, hold on one second. Why does it work that way? Here's what the log says. If I want to start with a 4 and end with a 4096, I want to know what's the exponent that changes a 4 to a 4096. Start with a 4, end with that. Oh, it's 6. See if you can pause it, and you try the next one. Try this one and this one down here. See if you can rewrite these in log form. All right, I'm going to call this log base 6 of 216 is going to be equal to 3. Same thing if I jump down here. This is going to be log base 4 of 2, 6, 2, 1, 4 is going to be equal to 9, like that. All right, let's see if we can go the other way around. We'll take these that are in log form, see if we can put them in exponential form. So it's going to go like this. The starting number is a 9, put down a 9. The ending number is an 81, put down an 81. What's the exponent? A 2, like that. So 9 squared is 81. See if you can pause it and try the other two. Start with a 3, end with a 27. The exponent is a 3. Start with a 5, end with 15,625, and the exponent is a 6, like that, and you've got it. The question that logs are trying to answer is, what's the exponent? That's really what they want to know. What's the exponent? They're going to give you two numbers. They're going to give you two numbers and then ask you that question. What's the exponent that changes the first one into the second one? All right, let's make it a touch trickier. I'm going to leave a number out and see if you can figure it out. So for the first one, it says log base 4 of 16. Here's what it's saying. It's saying start with a 4 and end with a 16. I want to know what exponent changes a 4 into a 16. We might say it's a 4. Well, no, it's not. 4 and a power 2 changes it into a 16. So this one is going to be a 2 because 4 squared is 16. All right, over here, this says start with a 4 and end with 256. I want to know what's the exponent that changes a 4 to a 256. So go on my paper. Start with 4, end with a 256. Ooh, looks like a 4 is going to be that one as well. All right, some of the other ones are tricky. See if you can figure them out. Pause it and see if you can figure it out. All right, this fraction one's tough. We're going to do this in two stages. It says this. Start with a 2. It's going to turn into 1/64th, and I want to know what exponent does that. Well, here's how it goes. Start with a 2 to a, let's just talk about a 64. Start with a 2, end with a 64. Looks like the answer is going to be a 6. So that's how we get it. Now we're talking about an exponent, and the question is what type of an exponent will take the number and give it a flip? Well, if I go 6 power 2, that's 64, and if I put a 2 power 6, that's 64, and a negative will flip it to make it a fraction, so my exponent is going to be a -6. All right, this is another straightforward one here. I have start with a 5, end with 3125. What's the exponent? Like that. Go on here, start with a 5, 3125. That's going to be 5, and we've got it. Ooh, this is a trickier one. Remember, we're going from big to small now. Start with a 16, end with a 4. What's the exponent? You might say, well, it's 1/4. Well, hold on. Start with a 16. Ooh, it's got to be this 16 because we're going to a 4. Start with a 16, go to a 4. Say, oh, it was a 2, but no, big to small actually makes it a fraction. So we have 1/2 there as well. All right, same thing over here. Start with a 125, end with a 25. This is probably as tricky as they're going to get because if I look at this, okay, 125. This is going to be a two-stepper. Watch this. I'm going to go 125, go over to 5, then back to 25. So there's two things we got to do. Let's go 125. If I go over to 5, that's 1/3. So I go 125 over to 5, 1/3 back to 25 with a power 2. So 3rd root power 2. So 3rd root power 2. So my answer is going to be 2/3 when you put those two together. That's probably as tricky as they're going to get. All right, the last topic that we're going to talk about today are common logs. The common log is a log with a base of 10. Base of 10. Okay? The thing about the common log is you usually don't write the base down. So if I see this right here, log 10, and there's no base down here, you're just going to assume that that's a 10. So another way that I could rewrite this is to call this is the same as log base 10 of 10. Well, when you have powers of 10, things actually work out quite nicely. Watch this. So I have log base 10, starts as a 10, ends as a 10. So what number changes a 10 into a 10? We're going to get x is equal to 1, and we've got it. This would say start as a 10, turn it into a 10,000. So what exponent changes a 10 into a 10,000? Well, hopefully we can just count zeros, and that's a pattern you can actually run with. Anytime you're logging powers of 10, log 10, 1, 0, answer's 1. Log 10,000, 4, 0, there's 4 of them. How about this one right here, log 0.01? Well, 1, 0, okay, this one's confusing, hold on. So log, this is a 10th, this is 100th, like that. So let's think about it. Starts as a 10, turns into 1 over 100, and I want to know the exponent. 2 steps. If I go 10 squared, that makes 100, and then a negative should flip it to make it 100th, so I get -2. So this is 100th, 2 decimal places, -2, and you've got it. Very last one seems tricky, but I think we can handle it. Square root 10. Remember, log base 10. This is 10. Remember, square root, I can write it as power 1/2, like that. So I can say, all right, what starts out as a 10, turns into 10 to the 1/2. What's the exponent? Oh, looks like my answer is going to be 1/2, like that. So something that we can learn to do is just cancel, circle, got your answer. All right, hopefully that was helpful.